Hi everybody. Today we're going to take a look at percent composition, empirical and molecular formulas. So when we want to find the percent composition, what that is we're looking at the amount of mass of one part of a compound is compared to the mass of the whole. So for example, sodium and chlorine make up sodium chloride. Now sodium is a smaller molecule than chlorine, and so we want to see like how much of a percentage is sodium chloride made up of sodium and how much of is made of chlorine. So first thing we're going to do is we need to figure out the molar mass of sodium chloride. Here we have it as 58.5. And then we need to divide each of the elements by the mass, each of the molar mass of the elements by the total molar mass. So sodium's 23 divided by 58.5, times that by 100%, I get 39.3. For chlorine, 35.5, which is the molar mass divided by the total, 58.5 times 100%, and I get 61.7. If it's a little bit more complicated, like ethanol, which has 2 carbons, 6 hydrogens, and 1 oxygen, I just have to make sure that number gets multiplied in there. For instance, there's 2 carbons, so I go 12.0 times 2 divided by 46. Or hydrogen, 1.0 for its molar mass, times 6 divided by 46. And I do the same thing for oxygen, except there's only one of them. And so now I got 52%, 13, and 34.8, add up 100%. Empirical formulas, on the other hand, talk about the mole. And basically what an empirical formula is, it looks at the most reduced, easiest, simplest version of a formula. So the easiest version is I take something like C6H6O6 and I just reduce it down. So the empirical formula for glucose here is just CH2O. You just reduce it. But a lot of times we don't know what the formula is, but we do know what the masses are because we've gone through some experimentation. So in this question, I'm looking for the empirical formula of a compound made up of 1.6 grams of chlorine and 0.9 grams of calcium. So first thing is I'm going to calculate the moles of each because we always compare moles. And then I'm going to divide by the least amount. So here I got 0.045 and 0.0224. This is the smallest amount here, the 0.0224. So I'm going to divide each by that. So when I do that, I get, for the chlorine, I get a 2, and for the calcium, I get a 1. So when I write the formula, there's 1 calcium compared to 2 chlorines. Now, an even more complex version of it is when I use percentages. And actually, it's not even more complex. It's pretty easy. There's just one trick to it. So here I got 68.8% carbon, 4.96% hydrogen, and 26.2% oxygen and benzoic acid. I want to know what the empirical formula is. So the trick to this is I go, okay, I want 100%. If I make it out of 100 grams, theoretically, I just change those percents into grams. So here I have 68.8, 4.96, and 26.2. And then, since I'm going to compare, I calculate the moles of each. So I get 5.73, 4.96, and 1.63. This is the smallest. So I'm going to divide each by the smallest. So I get 3.52, 3.03, and 1. Now, when I write that as a formula, I get C3.5H3O1. I can't have C3.5. So what I do is I just multiply the entire thing by 2 to even it out. So now I get C7H6O2. A molecular formula is the true formula, and we're generally given the empirical formula and asked to figure that out. So the empirical formula for benzene is CH. It has a molecular mass, a true mass, of 78.0. I want to know what the molecular formula is. So first thing is I find the empirical formula. So I go 12 for the carbon and 1 for the hydrogen, and I get 13. I then take my molecular mass, which I was given, divided by my empirical mass, which I figured out, and I get 6. And then all I do is I take this 6 and multiply it to my empirical formula. Hope that helps.